exercise. So part 2, still of chapter 7 SPSS, chapter 8 SPSS project. So now this exercise comes from your chapter 8, right? This is the pair t-text exercise. So here goes the data. The data is given to you, so you have to type in the data yourself. It says the impact of a campaign film on attitudes towards a political candidate was investigated. Prior to showing the film, let me see if I can blow up this image a bit. Yeah. Prior to showing the film, the attitudes of 15 people toward the candidate were assessed using a political likability scale. After completing the scale, the participants were shown a 20 minutes campaign film in favor of the candidate, and then they completed the likability scale a second time. The scores for the participants across the two administrations of the likability scales are reported in the figure to the right. And then it says the scores on the scale range from 20 to 100, with higher scores indicating more favorable attitudes towards the candidate. Enter the data in SPSS, perform the appropriate analysis to answer the questions. State the null and alternative hypothesis. State the research questions for the data. Did attitudes toward the candidate change after viewing the campaign film? In fact, this is your research question, and this is also where your null and hypothesis are going to stem from. So let's just start here. So the name of your test is not going to be a one sample t-test here, but it's a pair t-test. The conditions for a pair t-test are very similar to the one from the one sample t-test. The only difference is that you have random and dependent, right? Random and dependent samples. This is number one. Another thing that we have is we have unknown standard population, standard deviation population. We have unknown. It's unknown. We have dependent random, yes. I'm gonna say your sigma 1, sigma 2, we don't know it. I'm not sure. Do we have normal population? You guys can go back and check inside your notes. Let me quickly check your notes really quickly just to check. Make sure I have the conditions proper. Yeah. The populations are normal, or you have N1, N2 at least 30. I think that's how it works. Yes. Normal population, or yeah, normal population. So we're gonna assume we have normal populations, because in this case your N1 and N2 are not 30 at all. They're 25 or less. They're 15 even. So we're gonna make an assumption that you have normal populations. So this is all you need for a pair t-test, honestly. And the claim, now my research question, I'll plug it here. The research question is given to me here. It says, did the attitude toward the candidates changes or change after viewing the campaign film? That's the question. Now notice this is attitude ratings towards political campaign candidate before and after viewing the campaign film. So in fact, you want to see whether or not the mean attitude ratings towards the political candidate changes after the viewing of the campaign film. So my claim, honestly, is there is a difference in the mean attitude ratings toward a political candidate before and after viewing the campaign film. That's it. So see, this is going to be our HA, And we can literally write now difference. So now we can write mu 0 or mu 0 and also write our HA. Remember, pair t-test. So if it's a pair t-test, just insert your mu. Remember, it's a difference between your pairs. So it's a mu d. Remember that? Mu d, it's going to be different than 0. Okay. And this guy here is going to be mu d equal to 0. And that's it. But this is where your claim is at. Right here. My level of significance, of course, is alpha equals 0 0.05. That's what they gave us. Alpha equal to 0 0.05. Degree of freedom, very simple. You look at how many candidates or participants you have. 15. 15 minus 1. We are at 14. That's it. So we have our setup. This is our setup. So far, so good. This is the setup. Now let's go perform the test in SPSS. All right. Let's go perform the test in SPSS. So I already entered my data in SPSS, just so you know. You can pause the video and watch it, but before and after, those are the ratings. The variable view looks like this. Okay, I just, the measurements should be scale. Okay, and I labeled it before film and after film. That's it. It's all scales. This is what you have. So you go under analyze, you go to pair sample t-test. First variable is before film. You just drag it. And then the second variable is after. You drag it. That's it. It's as simple as that. There is nothing. Oh, I should have moved it here. Hold on. Let's remove this guy. Take it, drag it next to the other guy. So it knows this is where you compare. You're making comparison. For options, leave it at 95% because your alpha is 5%. But if your alpha was, for example, 1% or whatever, you will change this, right? If your alpha was 0.01, you will change it to 99. If your alpha was 0.1, you will change it to 90. I hope everybody's listening to me. But because my alpha is 0.05, I keep it at 95%. This is what I'm saying. All right, so once you have this, just click OK, and there goes your pair t-test. What do I really need? I don't need any correlation because I'm not going to look at that. This is the mean, and this is the standard deviation for each one of those data sets. So this is what I wanted. This is what I'm looking for. This table right here. Okay, so that's the table I'm looking for. Doesn't look too good. Let's see. I see. I need to open it up a bit more. So now, this is what I'm looking for. That's it. Now that I have that, I'm going to come back and insert it here. We insert it in. And we're ready to start. Okay. Doesn't look too, yeah, we can see. So there goes your p-value. There goes your t-statistic. There goes your degree of freedom. This is the mean and the standard deviation for the pair data, just so you know. So if you were to, do this on your calculator, right, you enter one in L1, L2. The difference is, this is going to be the mean of your pair data or your pair differences, and this is going to be the standard deviation. That's that. So my t-statistic here is negative 4.054. The p-value is 0.001, very close to 0. That's what we have so far. That's what we have. Okay. Making a decision. Let's make our decision. We make the decision. Look, your p-value is very, very, very low. So we're going to reject the null. Why? Because p-value is equal to 0.001, which is less than your alpha, which was at 0.05. That's it. How do we interpret the decision now? At the 5% significance level, we can conclude that the alternative, the claims in the alternative, there is enough evidence to support the claim that, and then we go pick up the claim. There is a difference. You will expect that, won't you? When I show the campaign clip, there should be a difference. There is a difference. Here we go. In the mean attitude ratings towards a political candidate before and after viewing the campaign film. Now, what remains for you to do is the following. Again, I'm going to ask you to answer this specific question. What is the effect size for the study? Would you characterize the effect size as small, medium, or large? Refer to this page in the book. Same thing, write the AP format. So you're going to go to your classwork, and this is what I'm talking about. This is the dependency test. This is the snippet from the book. You go to these specific pages, you locate where they talk about the effect size, and you come back and you comment in the Google Doc here. And then you go back again in the same page. Realize that the page is 102. It's on the same page. You see how they format the results, how they write the result of a study using AP format. So you look at it and you come back and you write your result as the same. In fact, it's very similar to this, but it's in AP format, right? Where they tell you exactly what to put inside your statement. And then you plug it here. And that's it. That's all you're going to need to do for me, all right? You do it for this exercise, right? And you'll do it also for the exercise at the top, and you will submit. This is it. I'm done, okay? So make sure you submit the work by Sunday. Good night, everybody. Good night. Bye-bye.